Hello. Now we are going to look at depreciation when we're talking about compound interest. So depreciation is just that the value of something drops over time. And usually those questions will be phrased as a percentage drop over time. So just like when we put money into a bank and we would gain interest, a percentage interest every year, as opposed to being given the same amount of money every year, usually depreciation will be done by percentage. Your value will go down by 10% each year or something like that. You can be given questions about depreciation where they say that the value of something drops by €100 every year. And that's fine. We just follow the question that we're given. But usually these will be given as percentage type questions, and we will handle them effectively as normal compound interest questions. The only difference is going to be that because our depreciation rate, our percentage that we're given, is how much we are lowering our original value, that means that our interest rate, our depreciation rate, gets taken away from the principal. So our final value will be the starting value multiplied by 1 minus the interest rate. So the difference in our formula is that instead of a plus, we have a minus. We are reducing, we are taking away a percentage each year. Other than that, the questions work the same as normal compound interest style questions. So let's have a look at a depreciation question here. A car is bought for €40,000. It depreciates at 20% per annum. Per annum means annually, per year. So annually would mean we do something once a year. Per annum means per year. So it depreciates at 20% per annum for 3 years. What's the value after 3 years? So we'll deal with part 2 in a minute. Let's write out our story for what's going on. So at present, we have a new car, or new to us anyway, which is worth €40,000. So that's the present value. That's P. And then after 3 years, so at the end of year 1, end of year 2, end of year 3, after 3 years, we have depreciated by 20% each year. So that's going to be P. And then we are going to have gone down by 1 minus I to the power of 3. So we are going to have dropped our value by 20% 3 times. And then part 2 is going to deal with year 4. Something different happens in year 4. So because there's no change in our interest rate, in our depreciation rate, and there's no improvements done to the car that might add to its value or anything like that, we're able to just calculate the depreciation over the entire 3 years. If we were told that the person who owned the car invested a certain amount of money to improve the car or got it nicer wheels or something like that and increased the value, say at the end of year 2, then we wouldn't be able to use the formula for the whole 3 years. So it's only if we see that there is no change except depreciation over a time period that we can just use our formula. But once we have drawn out our picture and read the story carefully, the two of them together should allow us to see whether we can use our formula or not. In this case, we can. So let's just work out our depreciation over the 3 years. So our principal, our starting value is our €40,000, cost of the car. The depreciation rate is 20%. And as with any interest rate, we instantly say per cent per 100, 0.2 from our calculator. The time is 3 years, and our interest rate is per annum. So both of those are in years, which we need them to be. They need to be in the same unit. And we are looking for the final value after 3 years. So at that point, we just sub into our formula. F is equal to the principal on 1 minus I. And we are very careful that we are subtracting this interest rate of 0.2, sorry, to the power of t, f is equal to 40,000 on 1 minus 0.2 to the power of 3. And this can all go in the calculator. And we get out 20,480. €20,480, and there's nothing more that needs to be done for that because there were no further complications in that question. Part 2. We continue on in the same situation, but at the end of the 4th year, the value of the car is €18,432. What was the rate of depreciation in the 4th year? Well, let's write down what we know. We know the final value at the end of year 4 was going to be 18,432. So we're at this point here in our story, and we need to get to here, or rather we know what happens when we get to here. We're going to have 18,432. So how do we get from having the final value in the end of the 3rd year is obviously enough going to be the beginning value at the beginning of the 4th year. So what we have at the end of the 3rd year will be what we have at the beginning of the 4th year when we roll over from December 31st to January 1st. So we know our final value given to us in the question. We just worked out the principal. That is the final value from year 3. And we are 20,480. The interest rate is what we are trying to work out, and the time is 1 year. So we have our formula, and we can write down our formula first and then write down all of the bits that we're trying to find, and then we can sub in. And I think I will start this up here so we're not changing line. So f is equal to p on 1 minus I to the t, and we're going to sub in. So we have our final value, 432 is equal to principal at the beginning of year 4 is the same as the end of year 3 that we calculated in part 1 times 1 minus the interest rate we don't know to the power of 1. Now to the power of 1 effectively has no effect. Any bracket any bracket written by itself, like x plus 3, a bracket like that is technically to the power of 1. So if we see a power of 1, we don't have to worry about it. It doesn't have any effect. It behaves like a normal bracket. So when we see this, now all we're trying to do is isolate I. So what we need to do is multiply this by each thing inside the bracket. And again, the power of 1 means that this is just a normal bracket. It's not squared or anything like that. So we have 18,432 is equal to 20480 minus 20480I. This is just an algebraic equation. All we are doing is solving for I. So I need to get rid of this 20,480 from the right hand side because I want to have I by itself. I don't want this number here, this constant here. When I subtract these two, I get minus 2048 is equal to minus 20480I. Then I divide by the coefficient of the letter, because minus 20,480 divided by minus 20,480 is just going to leave me with 1. And then I'll have I on the right hand side by itself. So when I do that division, I end up with a tenth, which I can also say is I would be 0.1 if I put it in decimal form. and I need to turn this into a percentage. So if I wrote it as a fraction, I'd multiply by 10 over 10 to get a denominator of 100, or if it is a decimal is really over 1. So to turn it into a percentage, percent per 100, I need to have a denominator of 100. So I need to multiply the 1 as the denominator by 100, and I end up with I is equal to 0.1 by 100 gives you 10 over 100. So I is equal to 10%. And that is what we need for now.